In the last video, we solved this nonlinear system, and we got 8 apparent solutions. So 8 pairs that fell out when we did a bunch of solving algebra to this system. But if we actually graph these, and I had a computer graph these, we have not learned how to graph equations that look like either one of these. But if we do graph them, or have a computer graph them, this is what we see. We see curves that cross each other only 4 times. Definitely this picture shows all of the points on our list. So if this really is the correct graph, we only have 4 solutions, which means that some of them must be extraneous. Remember, an extraneous solution is just a fancy way of saying something that shows up when we do a bunch of solving steps, but it's not really a solution to whatever we're trying to solve. And we had kind of a short list of steps that might introduce extraneous solutions. They might turn up if we multiply both sides of an equation by a variable expression. That happens because we might accidentally multiply by 0. They might show up if we take an even power of an even root, because we might lose sign information when we do that. They might show up when we combine log expressions, because that has the potential to mess with the domain. We started out with 2 negative numbers, but then when we combined them, we got something positive. And that sort of thing. Anything that messes with the domain, anything that loses information, has the potential to introduce extraneous solutions. In our example, we squared both sides. In particular, we squared a radical. And whenever we do that, we have to check for extraneous solutions. If you're ever not sure whether any of the moves you made had the potential to cause problems, just check. It doesn't take that much to actually check for extraneous solutions here. How do we do it? Well, remember in our last solving step, we used equation 2 to find values of y. And none of the steps that we did at that point risked introducing extraneous solutions. Right? We took the square root on both sides and introduced a plus or minus. So all 8 of these pairs are definitely solutions to equation 2. We just need to check, are they also solutions to equation 1? So I've already written out, plugging in all of the pairs x, y that we got into equation 1. And we'll just go through the list and see which ones really are solutions to equation 1. This is very much a job for a calculator. We'll have 2 squared plus 2 times 3 plus 3 squared. That's 19. So this one was a solution. We'll have 2 squared plus 2 times negative 3 plus negative 3 squared. That's 7. So this one was not a solution. Negative 2 squared plus negative 2 times 3 plus 3 squared. Oh, that's 7 again. So this one was not a solution. Negative 2 squared plus negative 2 times negative 3 plus negative 3 squared. Ah, that's 19 again. This one was a solution. So 2, 3 and 2, negative 3 were both solutions to the system. Let's see what else we've got. These are going to be a little bit less pleasant to plug in, but it's no problem. Let's see, 7 over root 3 squared plus 7 over root 3 times 8 over root 3 plus 8 over root 3 squared. That's looks like 56 1/3. That is not a solution. Okay, let's go back and make all of the 8 over root 3's negative. Rather than type that whole thing in again. Oh, if we have a negative 8 over root 3 instead, that's a 19. That is a solution. So 7 over root 3, negative 8 over root 3 actually was a solution. Okay. What if we make the 7 over root 3's negative? Ah, there's another 19. So negative 7 over root 3 and positive 8 over root 3 really is a solution. Now, we know that this last one isn't going to work because we've already found the 4 true solutions. Ordinarily, we wouldn't be going into this having looked at a graph. So ordinarily, we would have to check all 8. So we're going to go ahead and check all 8. I'm just going to take this one and make the 8 root 3's negative as well. And we get 56 1/3 again. So those seem to correspond to what we actually saw in the graph. Right, here's 2, 3, and negative 2, negative 3. And then this point, yeah, that's plausibly negative 7 over root 3, positive 8 over root 3. Right, that's plausible. And this is plausibly 7 over root 3, negative 8 over root 3. Those are definitely neither one of them nice integer points. So how do we know if we have extraneous solutions? The same way we always did. We go in and we plug them into the original system.